Hello everyone. In this video we are going to get introduced to TensorFlow. So by the last video you would have a complete knowledge of basically a nice knowledge of the working of neural networks. In this video we are going to see how to apply that by using Python programming, and we will use TensorFlow for that, and we will work on a small project of detecting counterfeit currency notes. So we will build a simple neural network architecture, and we would basically do all those forward pass, and we will fit our model, and yeah, that's all. So let us just start. So what is TensorFlow? It is a library in Python which provides us the functionality of creating a neural networks. So it has some nice functions already inbuilt to relieve us from most of our work of creating the neural networks. To get a better understanding and intuition of neural networks, let us navigate to playground.tensorflow.org. You can just open it in your browser, and you can just see how it is basically to get a better understanding of how neurons and the decision boundary, how each neuron separates, how it works. So the interface looks something like this. We have these hidden layers. We have two hidden layers here, and the last hidden layer they are calling it as output layer. So there are two neurons in the output layer, one neuron in the hidden layer, and there are two input units in the input layer. If we have a simple data set which requires a linear separation of boundaries, then we can easily use this neural network to create this boundary. You can see that this hidden layer is used to create this boundary. So one unit of hidden layer helps us to exactly create one linear decision boundary. But what if we have a complex data set and we use the exact same network? So we are using the exact same network, but this time we have a complex data set. So if you see that using one neuron in the hidden layer, it is only able to draw linear decision boundaries. So in that, we even after like 792 epochs, we aren't able to just separate the dataset. You can see that even in the training dataset, some of the orange dots also lie in the blue region. So this is not the proper decision boundaries. So if we make our model a little bit more complex, such that each neuron has a role in making one decision boundary. So if we increase the number of neurons, then we should get something right. So if I increase the number of hidden layer neurons, if we increase from 1 to 4, we see that we get a clean boundaries, and this is quite better decision boundary as compared to our last one, and it uses only 323 epochs to reach this much, it also has much less test loss and training losses. So yeah, that's the basic institution behind the neurons. So using these three neurons, we can create three linear boundaries, which can result in approximately a circle. You can see that this circle is almost looking like a triangle, but you can just keep on increasing more number of neurons, and this boundary would almost converge to a circular boundary. So if we try to separate more complex data set, we need more complex neurons and hidden layers, more number of units in the hidden layer. Then only we will be able to separate such complex kind of data sets, such as this spiral networks. So yeah, that's our basic intuition which I wanted to make you understand. So now let us catch counterfeiting nodes with our neural network. So we will use a banknotes.csv dataset. So you should know about what exactly is this dataset. These data were extracted from images that were taken from genuine and forged banknote-like specimens for digitization and industrial camera is used for prints inspection, and the final images had 400 cross 400 pixels. Due to the object length and distance, the investigated object grayscale pictures with a resolution of 660 dpi were gained, and we used some wavelet transform tool to extract some features from the images. What were those features? We will use those particular features as our x values here. So we had the variance of wavelet transform used as input. We have the skewness. These are statistical terms. We have the kurtosis. We also have the entropy of the image, which is used as input. And our last column would be counterfeit, which have two values, 0 or 1. If it is a 0, it is a non-counterfeit note, and if it is 1, it means it is a counterfeit currency. So we import our library, which we talked about, is TensorFlow as TF, and we also import NumPy pandas as we do generally for neural networks or for other machine learning algorithms. And from sklearn.model selection, we import train test split. Now this banknote.csv, we read it in a data frame and visualize it in this way. As I told you, we had the pixels values. So the image has some values of the pixels, and those pixels values are used to calculate some of the features of variance, skewness, kurtosis, and entropy. And we have the class whether it is a counterfeit note or not. So we just try to extract the x level and the y level values. So with open banknotes.csv as f, we just iterate through our reader, and for each row we just make our data set in evidence comma level format. So we create a dictionary. So we have a list of dictionaries, and each dictionary has evidence comma level format of data. So we get our data in this way. And so yeah, we have we can collect evidence in a separate exclusive variable called evidence, and as well as labels. So we easily get that, and using those evidence and labels, we can now use the train test split. We first make our data frame. Let's say we make the labels will go to the y values. So we have the x values as well as the y values, and we by using train test split, we dfx and dfy, we create training as well as testing data sets, and we use the test size as 40%. And using model, we create a model which is tf.keras.models.sequential. So from TensorFlow, we create a model. We say that we go to the keras module inside the TensorFlow, and we go inside the module and then tell that go ahead and give me a sequential model. So then we add inside this model, we add a layer which has 8 neurons and whose input shape is 4, because we have 4 features, and whose activation function is ReLU. And we add more we can add more layer, right? In this layer would be our output layer, which has only 1 neuron, and which would output either 0 or 1, and it has an activation function of sigmoid. So it is an S-shaped curve which gives us a nice decision whether it is a 0 or 1 output. So in this way, we are basically creating a really simple model. So in some of the next videos, I will show how to create more complex models in convolutional neural networks. So yeah, now after the model is created, we need to compile our model using our optimizer functions. So as I told you, ADAM optimizer is the most used optimizer. It uses various things such as stochastic gradient descent, the uses of adaptive learning rate, and a lot of other things. It combines a lot of other optimizer functions to give, and it is the most famous optimization function known in market nowadays. And this loss function, we use it as binary cross entropy loss. It is also known as the log loss function. And we use our matrices as accuracy. Then we fit our model. We use X-train and Y-trains to fit through 20 epochs, and we train that. It takes some time to train that. And binary cross entropy, I have written the formula here. So it is the log loss cross entropy. So after the model is fitted, it goes through 20 epochs. Each time the back propagation is done, and each time the weights are updated as I explained you in the neural networks algorithm. So finally we can also test, we can simply use model.evaluate to test whether what is the accuracy of our data set. As you can see here, as number of epochs increases, our accuracy also increases from 36.57% all the way. In the 6th epoch it becomes 82.26%, and in the 20th epoch it becomes 98.3% accurate. And we are even not overfitting our model. This can be proved by using the test dataset. In the test dataset, our accuracy is also high, which is 97.81%. Now this verbose equals to 2, what does that mean? So by setting verbose as 0, 1 or 2, you can just say how do you want to see the training process for each epoch. So verbose equals to 2 will show you nothing, it would just train. Verbose equals to 1, which is the default value, will show you an animated progress bar like this. So as you train your model, your progress bar will keep on increasing here, and that's for verbose equals to 1. And in why I use verbose equals to 2, that's because our model is in evaluation stage. We don't want any animation here, we just want our accuracy. What is the final accuracy? So yeah, that's all from this video. So we would meet in the next video about computer vision, and we will start a series of videos on small videos on computer vision, which would finally lead us to convolutional neural networks. So yeah, that's all from this video. Thanks for watching it till the end.